Howdy once again, it's tubalcain. Welcome back to the workshop, and this is tips number 533, which is part 4 of the rebuild restoration of the 1x42-inch Mead belt sander, band sander. Be sure and go back and watch the other videos so you know what I'm doing here. So let's get started. I'm still waiting in the mail for new bearings for this upper wheel. So in the meantime, I have turned my attention to mounting the motor. Now you may recognize this motor. It was originally on that Duro drill press, and it was grossly underpowered for that application. It is not capacitor start. It may be underpowered for this application. I don't know. But anyway, I put that, that's a 32-inch belt. That was the belt off that it already had. And remember that the holes here do not line up because there was another motor on there. So I have positioned the motor such that it's perfectly in line, I hope, and square and all that good stuff. But if I'm just a little bit off, I can account for that by moving the pulley in or out just a little bit on the motor shaft. But I've already marked on that black PVC with a copper colored pencil. It shows up real nicely where I'm going to drill, and the bolts, let's see, where are the bolts? These are 5/16 bolts. I think I'll use some new bolts. Those are kind of gnarly looking, but I need to lay out and drill 1/4-inch holes and tap them 5/16/18. You know what? I was remiss here. I should have painted this board before I mounted the sander on it. I should have painted it black, but initially I thought that it was black plastic. So I didn't give it a thought until I sanded these corners here and realized that it's that gray PVC. So, well, I'm not going to go back and do that, but it would look a lot better because it is marred up pretty bad. And we got fresh paint here, and the paint on this gray motor is in pretty good condition, so I'm doing nothing with that. Alright, I drilled the 4 holes, and I drilled a couple other ones here, just as waste, that's a waste stock in here, it doesn't matter, just to see if this was possible to tap this with the DeWalt drill, and it is. And I'm going to do that in a second, but let me correct myself. I told you that this is probably PVC. Well, when drilling this, it smelled nothing like PVC, and this is a known piece of PVC. So then I drilled this piece. Where is it? Right here. And the chips that came out of there and the smell were totally different than the PVC. So I have determined this is some kind of phenolic. It had that phenolic smell. So this appears to be some kind of board that maybe came off of electrical apparatus. Do you remember when they used to mount electrical things on some kind of plastic years ago? It was non-conductive, so I think that's what this is. Alright, that's a tapered 5/16/18 tap, and I know it'll work fine, but I hope that I'm tapping it fairly straight. But I know the holes are straight, but you know, it's always a crapshoot when you're doing it by hand. And that worked great. And again, the odor, I just sniffed the tap. Nothing like PVC. Again, I'm treating myself to brand new hardware. You know, after all, I got almost 1 million fasteners, so what am I saving it for? You know, that kind of stuff I need to throw out, and I will. I'm not saving it anymore. That's crazy. I know there's people in different parts of the world that are saying, don't throw that away. You know, we can't get those. I know it, but alright, I'll go ahead and fasten these down. A little awkward. I can't use any power tools for that, and I am using a washer as well. Alright, I've been working on the wiring for a while, and there were just all kinds of things wrong. Number one, I put a new, remember this was just pigtails on here, and I wanted there to be a female receptacle, and I got it mounted, and that's fine. Alright, then I started doing a little testing, and several things were wrong here. First of all, I took the lid cover off the box, and the ground wire runs right through. They never did cut it or bond it to the box, so that needs to be done. I think that is correct, that the box also should be grounded. All right, and then I plugged it in. Where is it? I'll talk about this. Let me talk about this plug first of all. There was a plug on there, and this is what it looked like. I took the cover off it, and you can see what a nightmare it is to try to wrap the wires around this old style plug, and I absolutely hate these, so I thought, you know, I'm just going to cut it off and throw it away. Also, it was missing one screw. And I saved the little plastic cover that was on this so that it can go on the motor plug, which is also that older style, because it was missing that little cover. Where is it? I got it laying here someplace, but I'll put it on there. Okay, this is the kind of male plug that I like. And, well, what's the big deal, you're thinking? Well, and here's another one. It's a Hubble brand, and I had several of those in stock, brand new. But I'll tell you what I like about these, and it's just not exclusive to this brand. That's a different brand. I think that's Eagle. No, that's Leviton. That's a good one too. But let me show you what I like about this. Not only that, do they have a clamp here that'll fit almost any size, and they brag about that on the box, but they use these triple start threads on these screws. Well, so does the yellow one, so it's, you know, you don't need many turns. But I'm thinking that probably over the years thousands of electricians quit the trade because they hated working with this kind of deal. So they came up with something so much better here. So you just install the wires, you back off the screw here, and they're clamps, and you strip the wire, and you don't need to strip very much compared to the old ones where you had to wrap it around. And you stick it in there and tighten it down. And then the neat thing about this is they're clear, so you can truly see whether or not your wire is in the clamp. So you got a little window. And I thought, well, how ingenious is that? So I really like that brand. And I know I'm way off topic here, but I thought, well, before I hook the motor up, where's the other plug? Hook the motor up and run the motor. I'm going to go ahead and double check it with one of these. And, you know, it was wrong. I got the wrong reading, and I thought, well, what in the world is wrong? I know it's nothing that well, of course it couldn't be anything I did wrong, but upon examining this and testing it, I had the old meter out, and you know, and I do like an analog meter, and I was using an ohm meter just to check continuity. But Bubba had hot and neutral reversed in this plug. Not, so anyway. All right, so I got that all corrected, and let me plug this in now. I think that's... And there we got two greens, which means, if you read the legend here, that it's correct. So the wiring is now correct. Well, no wonder I couldn't find that little bugger. It's transparent. So now I've got the plug protected and covered. I really should replace that, but again, not in the mood. Have you ever noticed that much of what I do is controlled by my moods? And then I need to bond this switch box with the ground, and the wiring is done, so I won't talk any more about that. I'm back again, and it's the next day, and I've been waiting all morning for the mailman, and I finally went out there because I'm waiting for the bearings to put into this wheel. And according to the tracking number, they were in St. Louis last night, but they still didn't come. All that was in the mail with a bunch of dunning letters, so I'll get to that tomorrow. So today I think I'll just have to tackle one of the other parts that I need to make, namely this wheel. This idler wheel. Remember, one was missing, so let's get started on making another one. This is the parts list for the bell saw bandsander, and the more I examine this, the more convinced I am that the bell saw was actually a Mead, probably rebadged, because I just don't see anything that's really any different. But notice here in the parts list that there's, this is the lower wheel, this is the upper wheel, and then there were two idler wheels, one that goes on that swing arm, and one that goes on the back pin that I showed you just a few minutes ago. And these two really are identical. That is, the part number is the same. Notice that there's a bearing in there, an oil-light bearing, so I'll be dealing with that too. Well, how am I going to go about making one of these? I certainly could just start with solid bar stock, aluminum stock, but that would be kind of laborious. I'll show you how I did it. Here's the original. Notice that it's about 2 inches in diameter, maybe a little bit bigger. 1 inch wide. Has a 1/4 inch hole in there along with that oil light bearing. It's die cast zinc, and it has a crown on it. So I need one of them, but I made several, and I'll show you how I did it. Well, you know, I'm big into 3D patterns, 3D printed patterns, and I'm still shocked at how little interest there is in my videos on this. And I know that we have people out there that are not foundry men, that have no foundry and everything, but you just do not show the enthusiasm for this that I did. So, you know, I didn't want to make a wooden pattern. That would take so long. I certainly could do it, but it has to be a 2-piece split pattern. That takes a lot of time. By a lot of times, I mean it would take all morning. So here's what I did. This is the relatively large, well, it's neither large nor small, it's 5 inches. And that was off of my 2x48. Remember, that was done by Kevin just a few months ago. So I decided, I like that show, The Incredible Shrinking Man. Did you ever see that? So I thought, I'm going to shrink this. I saw that movie in 1956. I was 12 years old. It left me quite an impression on me. I still like to watch it. Who cares? All right. So anyway, I had this. Can I shrink it? Yes. All I have to do is go back into the slicing program, if you know what I mean, and reduce it by percentage or size or whatever until I get it down to 2 inches to this size. Well, I liked the idea of the extended hub here. You'll see why in a little bit, as opposed to this side. So in fact, I made 2 of these. I didn't use this at all. Set that off to the side. I made 2 of these. I printed them, shrunk them down, and there it is. The Incredible Shrinking Man. Isn't that awesome? The only thing that threw me off a little bit on this is that I failed to keep in mind that all of the dimensions would be reduced, including the thickness of the wall here. So that left me with a rather thin wall here, which I think might be troublesome when I go to machine it. Maybe not. I'm just imagining that. But in fact, this is pretty thin. So that's really a good match, isn't it? Just by shrinking down. Almost no work at all. And I made 4 halves so that I could, why? So that I could cast 2 at the same time. And I cast them along with the table. You'll see that in the next clip or the next part, some of the castings. But isn't that neat? I don't think there's anybody in all of Christendom that could deny the usefulness of 3D printing in this type of application. So when the weather was still nice, and by the way, it snowed last night. We had about 2 inches of snow, but it's already melting. It's a very wet snow. I didn't even get the snowblower out, although this is too little to amount to, who cares? All right, so I cast up a couple. There they are. I only need 1, but I always cast up some extras. A little bit rough around the parting line. Why? Well, we always get that horrible, we call it elephant's foot right there. Now that probably could have been sanded off of the PLA pattern here, but that's been troublesome, but I see that everybody has that problem. That's going to get sanded off, so I'll take that onto the sander and just rough that down. That's the gate, of course, but that's a pretty decent casting. And in fact, about a month ago. I've been working on this for a long time while the weather was still good. This was a bad casting. You can see some sand fell in. So this is a piece of waste stock really that I was practicing on. So I turned it to 2-inch, faced it to 1-inch, including the hubs, drilled and reamed it 3/8 because that bearing is 3/8 OD and 1/4 ID. So let me get started on that. I won't show everything because it would take too long. It would need to be a 30-minute video just for this alone. And this is only one part of this entire job. So let me clean this up and I'll be right back with you. Okay, through the magic of modern television, I'm back already. Now I cleaned this up, but I circled the spot where the gate went in because I do not want a chuck jaw to ride on that in case it's a little bit irregular. And I use a parallel here to put it into the chuck. I'm on the closing lathe and get it squared up, and I want some of this to stick out of the chuck. Two things. First of all, I hope it didn't seem like I was scolding you in that little rant that I had about 3D patterns. But sometimes I go into a rage without realizing it, so I think that's what I did right there. But I apologize for that. Now what I'm going to do here, I got this all set up. I'm going to face the hub and I'm going to face the rim. Now order of operations is pretty important in some jobs that you do, the same as it's important in mathematics. I have one of these wonderful little boring bars from Solid Rock Machine Shop here that I'm using. It's all mounted, and what I'm going to do here, the hub here of course is tapered. I'm going to make it perfectly cylindrical by boring, and I'll be running I'm not boring internally, I'm running the chuck backwards, that is in reverse, and just going to clean up the hub so it is no longer tapered, because that is the surface that I intend to hold in another lathe here in a minute. You'll see why. You know, there's a lot of different ways of holding your work, and it's really important. It doesn't matter how you do it as long as you do it properly, but like I say, there are different ways of doing it. Now I noticed on this one that I made a month ago, I forgot how I held it. You can see that I did not turn the hub down on this one. Originally I wanted to hold it with a lathe mandrel between centers to do that operation, but of all things, believe it or not, tubalcain does not own a 3/8 lathe mandrel. Well, I might have used these Breakheart expanding mandrels in this size. That's probably what I did, but I don't really remember. So what I'm going to do anyway today is to hold this in the 3-jaw chuck and the Atlas lathe, drill it and ream it 3/8, face it here, and then ultimately face this hub so that it's flush. Now let me explain, I talked a little earlier why I wanted this hub to be extra long when I selected that pattern. That was so that I had extra length to hold it with the chuck jaws, and it has to be a small chuck that will fit in here. That's why I'm switching lathes from the closing to the Atlas. So holding it by that, I want to do, again, the facing and the taper turning and the drilling and reaming, all in one step for true concentricity. And remember, the diameter of this is not very critical. I'm just going to take it till I clean it up. It needs to be about 2-inch, but it could matter less, really. Let's go to the Atlas lathe. Okay, I'm going to machine the hub off and the rim. And now I'm turning a 2-degree taper by the compound rest method. Now I have reversed the compound to 2 degrees in the other direction, and I'm turning the back side of the crown also at 2 degrees. Notice that I put a piece of lead in there to cut the ringing and the chatter. There was just a little bit of that. And the crown is right in the middle. And do not take the work out until you're sure you've finished all of the operations. Be careful when you work on the lathe. Observe all the safety rules and make sure you wear your glasses or goggles. Now it's really done on this side, and I'm flipping it over, and I want to face the hub off on this side so it is the same thickness as this. So I switch chucks. It's a little bit larger chuck, and I'm going to hold it like this ever so lightly, so that I don't put any chuck marks on it. I could wrap it in lead or copper or something like that, but I'm just going to hold it real gingerly, face that off, and that also gives me a chance to chamfer that corner and the other cleanup operations. I won't show that. Several things now. First of all, I told you I was going to hold this thing very gingerly and lightly. Well, it was too light, and it kind of came loose, and I did put some marks on it, so I should have taken the time to wrap it in lead or copper, but it'll be all right. Notice how I had to put the piece of lead in there to stop the ringing. I don't know if that is noticeable on the video, but boy, it was just a high-pitched squeal that even my ears can hear. Did you also notice that I used some of this Tap Magic here? Now, Richard Hawks up at Shar sent me several samples, and this newer formula here can be used for aluminum or other metals. Remember, originally it wasn't so oily. Now it's yellow and oily. It used to be clear and evaporate, and if you use it on aluminum, your work turned into tar. That worked pretty darn good. Thank you, Richard. Now next I want to install some oil-light bushings or bearings, like you see here. So I need 3/8 OD, 1/4 inch ID. I have a little selection here from Ron, and in this selection I already took a couple out of there, and they weren't long enough to put it all in as one piece. In other words, I needed a 1-incher. So I took two, I think they were 5/8, and I faced them off so they equal 1 inch, and I'll press them in from each side. Does everybody understand what oil-light bearings are? They're pre-lubricated, that's a trademark, pre-lubricated sintered metal. It's actually like a sponge. If you could examine it even closer than this, you would realize that it's so porous that it can hold the oil. Now let me compare it here to another bushing out of that selection there. It's not oil-light, it is just turned down brass. But this is what I'm going to use. I pressed one in from each side. I just used the drill press, pushed it in with a chuck. And they come just a little bit oversized. It's important also to remember that if you press them in and you squeeze them and reduce the diameter, and you have to run a reamer through there, that often the reamer will smear over and remove the porosity and prevent it from lubricating. So avoid reaming it. Alright, that job is done, and they look pretty good from this to this to this, simulating this. Boy, the aluminum is a lot lighter. Alright, that concludes this part of the video. Hope you enjoyed it, and I'll see you in the next part. This is tubalcain saying so long for now.